Hello, this is Mr. Miller for lesson 5-2, using intercepts. As you can see from this first page, there's two ways that we can find intercepts. One, through an equation. The second way, through a graph. Again, if it ever wants you to graph and you can find it through the equation, which in my opinion is easier, then do not graph it. Do it whichever way you can do it. Okay, so we need to know what the x-intercept is and what the y-intercept is. So the x-intercept is the point where it crosses the x-axis. The y-coordinate for this point is always 0, so we're either just going left or right here, we're never going up or down. And the y-intercept is pretty much the opposite. So the point where it crosses the y-axis, the x-coordinate of this point is always 0, so we're only going up or down, never left or right. And this is kind of a picture of what that says. Okay, so our x-intercept is going to be, in this case it's to the right. Our y-intercept in this case is up. So we're never going right and up, or left and down when we're finding intercepts. Intercept just means, kind of like in football, an interception where it's crossing the line, kind of like an interception where it's crossing to the other team. So for a problem like this, we're going to have two answers. So for one answer, we want to say what the x-intercept is. And so we can kind of see the x-intercept for this one is -2. So we would just write x int -2. And then we can see our y-intercept for this problem is up here. So it's at +1. So our y-intercept is 1. Okay. This is basically all we need to graph. Last time we talked about finding the ABC, and this kind of goes along with that, where now we're finding intercepts. So instead of graphing those big long problems, picking 3 points, plugging in for the formulas, basically if we can find intercepts, we can get 2 dots on our graph that are hopefully 2 good dots that represent what the graph is doing, and we can just be done with that. And I'll kind of show you what I'm talking about when we get to an equation. Let's look at this graph and see if we can find the intercepts here. So the x-intercept looks like we're going left 2 again, so we're going to be at -2. And then the y-intercept looks to be up 3, so it's going to be a +3. So here's some more information on how to find those intercepts, and this is with an equation. So to find the x-intercept, replace the y with 0 and then solve for x. To find the y-intercept, replace the x with 0 and solve for y. Okay, so it doesn't matter which one we try to solve first. Let's rewrite this. Let's pretend that we're going for the x-intercept first. So we have 5x, and now instead of -2y, it said put in 0 for y. So 2 times 0 equals 10. Well, really with that 2 times 0, that pretty much gets eliminated because anything times 0 is 0. So what I'm really left with is 5x equals 10. And then so I know my x-intercept would have to be 2 because 5 times 2 is 10. Okay, and then we would do that all over again. So let's get rid of all this. And now we would do it again for the y-intercept. Okay, so again I'm going to rewrite it, except now I'm going to put in 0 for my x. So 5 times 0 minus 2 times y equals 10. Okay, so again my 5 times 0 is pretty much going to eliminate, because anything times 0 is 0. So I'm just left with -2y equals 10. And again, if I want to figure out what y would equal to make those both the same, it would end up being -5. So now if I had a graph, I would plug in 2 for my x-intercept, and then -5 for my y-intercept, and I am completely done graphing. If you remember when we did this last chapter, I'd have to pick 3 numbers, so pick 0, for x, and I would see what y is, and pick all these things for x to see what y is, and at least get 3 points to graph it. I think this is a much faster, simpler way to do it. Hopefully we agree when we do some more problems like this in class. We can even do it when we're talking about big long word problems like this. So Trish can run 800 or 200 meter dash in 25 seconds. So the function f of x, remember that's just another fancy word for y, is 200 minus 8x, which gives the distance remaining. Okay, and then we would have to make a graph for this. So usually 200, that's going to be a big number, but kind of the same thing, where if we plug in different numbers for y equals 200 minus 8x. Okay, so remember, I'm going to plug in a 0 for x, figure out what y is, plug in a 0 for y to figure out what x is. Well, that's already kind of done for us down here. So if I put in a 0 for x, that means 200 minus 0 equals y. Well, that's pretty simple, because then if 200 equals y, y has to be 200. And then if I do it the other way, where I plug in a 0 down here for y, so 0 equals 200 minus 8x. Well, I have to figure out 8 times what gives me 200, so that 200 minus 200 would give me 0, and it happens to be 25. Okay, so kind of the same thing. I need to graph 0 and 200, 25 and 0, and it would look like this. So there's my 0 and 200, where I'm just going up 200, and left, right, 0. And here's my right 25, where I'm going up or up and down, nothing. So it kind of makes it a little simpler there. I'm just graphing those 2 points, and I'm going to get the right answer with my straight lines. Let's do one more. So here's one where if I put in 0 for y, I'm going to end up with negative x plus 0 equals negative 6. So the only thing that x can be there is 6. And then kind of the same thing for my y's. If I wanted to figure out what my y is going to be, I put in a 0 for x plus 3y equals negative 6. And 3 times negative 2 is going to give me negative 6. So then I would just graph 6, negative 2, and I would be finished.